Okay, today's paper is Paper2Rebuttal, a multi-agent framework for transparent author response assistance by Qianli Ma, Chang Guo, and their team from Shanghai Jiaotong University.
And we are breaking this one down today.
So the core problem here is something a lot of you have probably faced, the hallucination trap during peer review.
Yeah, you use a standard LLM to help write a rebuttal, and it starts making up experimental results to make the reviewer happy.
Right. And on the other hand, just using a chat-based model, that's often really opaque, and you get that context thrashing we've talked about before.
So the authors introduce RebuttalAgent. It's a multi-agent framework, and the whole idea is to treat rebuttal writing less like text generation.
And more like an evidence-centric planning task.
Exactly.
The key innovation really is this verify then write workflow. It actually breaks down reviews into what they call atomic concerns.
Then it retrieves specific evidence from the paper or even from the web, which is huge.
And this is the most important part. It generates a strategic plan with a to-do list for new experiments instead of just faking the data.
And when they tested this on their new data set, RebuttalBench, which they built from ICLR open review threads, it significantly outperformed some really strong baselines. We're talking GPT-5 Mini, DeepSeek v3.2, things like that.
Okay, so that's the 1-minute abstract. Now let's really get into it, because if you're a researcher or an ML engineer getting ready for, conference season, this paper is tackling a very real pain point.
Oh, for sure. The rebuttal phase, it's a pressure cooker. You submit to a top conference like ICLR, you get the reviews back, and you have this tiny window to respond.
And the temptation is just to copy-paste the review into a model and hit go.
But that just doesn't work. The paper really clearly lays out why it fails. They talk about two paradigms people are using now. First is direct-to-text.
This is where you'd have like a model fine-tuned on paper response pairs.
Right, supervised fine-tuning. And on the surface, that sounds like the right move, Train it on what a successful rebuttal looks like.
But what does a successful rebuttal often include?
New experiments, real ones. And that's the failure mode. The model just becomes a yes man. It learns the style of a good response, which might be, we ran the ablation and the results are in this table, but it can't run the code.
So it just hallucinates the table.
Yeah.
It's optimizing for politeness, not facts.
It's overfitting to the acceptance signal, basically.
Okay, so that's paradigm one. The second one is the chat LLM approach. Just pasting into Chat GPT or Gemini.
The problem there is what they call context thrashing. You're giving it a 15-page PDF, a 2-page review.
And even with these massive context windows,
the reasoning just gets muddy. The model loses the plot. It can't track which sentence in your paper is supposed to refute which specific point from the reviewer. It's a black box.
So this brings us to RebuttalAgent. The author's whole philosophy is shifting from just generating text to evidence-centric planning.
Yeah, and it's a pipeline. It's a whole system of specialized agents working together. You've got a parser, an extractor, a strategist, a drafter.
Like an assembly line for arguments. Let's start with stage one, structuring the input. Because they don't just dump the PDF into the prompt.
No, absolutely not. First, a parser and a compressor create what they call a paragraph indexed format.
What does that actually mean?
Think of it like a structured summary or a map of the paper. It's condensed to save on tokens, but it keeps the logical skeleton. Section 2 connects to Section 3.
Okay, so it has the map of the paper. What about the review?
That's where the extractor agent comes in. It takes the raw review and breaks it down into atomic concerns.
This is a really key step, I think.
It's crucial because a reviewer will write one big, messy sentence like, the method is novel, but you didn't compare to Smith at all, and I'm not convinced about the efficiency claims.
And that's not 1 point.
It's 3 points. Novelty, a missing citation, and an efficiency question. The extractor splits them up.
And they have a checker for that, right? To make sure nothing gets lost.
Yeah, a lightweight coverage checker. It basically makes sure the atomized list fully represents the original review before moving on.
So we have a structured paper and a clean to-do list of concerns. Now, stage 2, evidence construction. This is where they solve that context thrashing issue with something called the concern-conditioned hybrid context.
It's a bit of a mouthful, but the idea is really clever. For each one of those atomic concerns, it builds a custom context window.
So it's not using the whole paper every time.
No, it uses the compressed summary of the whole paper just for global context. But then it injects the full high-fidelity raw text from the 1 or 2 paragraphs that are actually relevant to that specific concern.
It's like foveated rendering and graphics. high res where you're looking, low res in the periphery.
That's a perfect analogy. It focuses the model's attention. But honestly, the real game changer in this stage is the external search.
For when the reviewer hits you with, why didn't you compare to this paper that just came out last week?
Exactly. That's the knowledge cutoff problem. A standard agent just dies there. But RebuttalAgent has a search planner. It literally goes and hits the ArcSev API.
Okay, walk us through that flow.
The planner generates a query from the concern, it pulls some papers, then a screening agent reads the abstracts to see if they're relevant.
So it's not just grabbing the first result.
No, it filters, and then it generates what they call an evidence brief, a little citation-ready summary of that external paper. And that brief gets passed down the line to the agent that actually writes the response.
So it's doing a miniature real-time literature review for you?
It is, and in their ablation studies, when they turned that module off, the scores for things like relevance and communication just plummeted. It's a huge deal.
Okay, that brings us to stage 3, the core logic, planning and drafting, with the strategist agent.
Yeah, the strategist is the brain of the operation. It looks at every single atomic concern and sorts it into one of 2 buckets.
Which are?
Interpretative defense or necessary intervention.
Interpretative defense sounds pretty straightforward. That's like, reviewer, you misunderstood, please see section 4.1.
Correct. But necessary intervention, that's the anti-hallucination kill switch. That's when the agent says, you know what, the reviewer has a point. We actually need new data to answer this.
And crucially, when it decides that,
it explicitly inhibits result generation. It stops itself from writing. Instead of inventing a fake table of results, it generates a to-do list for the human author.
it becomes a project manager. It says, action item, run this new ablation.
And that's the human-in-the-loop moment. The system literally pauses and shows you the plan. You, the scientist, have to sign off on it and say, yes, I will do this experiment.
What happens to the draft in the meantime, if the experiment will take a few days?
The drafter agent will go ahead and write the response, but it will insert a specific placeholder like TBD.
So the output text actually says, as requested, we ran the experiment and our method achieved an accuracy of TBD%.
Precisely. It's such a simple, elegant engineering solution, but it completely sidesteps the lying AI problem. The AI structures the argument, but it forces the human to be the source of ground truth.
Let's talk about how they even tested this, because you can't use something like BLEU score for this kind of task.
Oh, completely meaningless. A fluent, well-written response could be factually wrong or strategically terrible. So the authors had to build their own benchmark. RebuttalBench.
And this came from real data.
Yeah. ICLR 2023 Open Review. They scraped about 9,300 review rebuttal pairs, and they had a ground truth signal because they could see the reviewer's final comment, concerns resolved, or if they raised their score.
So they have positive and negative examples. And to judge the generated responses, they used an LLM as a judge.
Right. They used Gemini 3 Flash with really detailed rubric, scoring from 0 to 5 on 3 different axes.
Which were R score, A score, and C score.
Right. R for relevance, did it address the point? A for argumentation was the logic sound. And C for communication was the tone right.
And RebuttalAgent beat the direct prompting baselines pretty consistently.
It did, across the board. But there was this really interesting finding about which models benefited the most from the Agentic framework.
It was the weaker models, wasn't it?
Yes, exactly. The performance lift was much bigger when you put a weaker base model, like GPT-5 Mini, inside the RebuttalAgent framework compared to a stronger one.
Which suggests the framework itself is doing a lot of the heavy lifting. It's like a scaffold for reasoning.
It totally is. It proves that you don't necessarily need the smartest possible model if you have a really smart process. By breaking the task down into these specialized steps, you lower the cognitive burden on any one agent.
Let's make this more concrete with that case study they had about Proposition 1.
Ah, yes, this was a great example. A reviewer claimed there was a mathematical contradiction in the paper's Proposition 1.
A standard model would probably just apologize profusely.
And that's what the baseline did. It generated this long, fluffy, defensive paragraph that didn't actually address the math at all. It was just trying to be polite.
Or RebuttalAgent.
Its strategist agent analyzed the claim and realized it wasn't a contradiction, it was just a misunderstanding of an upper bound. But it also decided that just saying you're wrong wasn't going to be convincing enough.
It needed an intervention.
It needed an intervention, so it generated a 2-item action plan for the author. Item 1, draft a formal monotonicity lemma and add it to the appendix.
Wow.
Item 2, generate new scatter plots to visualize this relationship. It literally told the author to go write a new proof.
It's not just helping you write, it's guiding your research strategy. It identified a weakness in the paper's defense and ordered reinforcements.
That's why I think the to-do list feature is maybe the most valuable part of this. It cuts through all the emotion of getting a tough review and just gives you a clear, actionable checklist.
I want to circle back to something we kind of skipped over. Global consistency. That was one of their 4 pillars.
Right. This is huge. You can't tell reviewer 1 one thing and reviewer 3 something completely different. Like if you tell one you removed a data set, but tell another you kept it for robustness, you're caught.
So how does the agent manage that?
The Strategist Agent maintains state across all the different reviewer responses it's working on. It has visibility into the plans it's made for the other reviewers, so it won't contradict itself. It avoids that silo effect you get from separate chat sessions.
So, stepping back, what are the broader implications here? This is about rebuttals, but this whole plan, verify, draft architecture seems very generalizable.
Oh, absolutely. Think about writing technical documentation, or a post-mortem for an incident, or even just writing the first draft of the paper itself. The core insight is that planning an argument is a different cognitive task from drafting the prose.
And our current chat models just mash those 2 things together.
Exactly. We ask it to think and write in the same continuous stream of tokens. This paper shows that using specialized agents for specialized tasks, one for reading, one for planning, one for searching, one for writing, just gets better results.
It's the whole agentic workflow idea that's been gaining traction, moving from a single prompt to an iterative process.
For sure.
Okay, so I want to end with a more provocative thought. The paper mentions related work on agent reviewers.
Agents designed to actually write the tier reviews.
So if you have agent reviewers writing the critique, and you have rebuttal agents writing the defense,
You're starting to close the loop.
are we heading towards a world where an AI writes the paper, a different AI reviews it, and a third AI rebuts the review?
And an AI area chair just tallies the scores at the end. It's a real question.
At what point do we, the human scientists, just become the human-in-the-loop part of the machine? The person who just physically clicks run on the experiment the strategist agent told us to do?
The optimistic view is that this frees us up to focus on the really creative parts, the initial hypothesis, the core idea, the experimental design.
We become the architects, and the AIs are the construction crew and the building inspectors.
The pessimistic view, though, is that we could get disengaged from the actual scientific debate. If you just look at the to-do list from RebuttalAgent, you might not wrestle with the criticism in the same way, and that struggle. That's often where the real learning and the best science comes from.
That's the danger. Convenience can lead to complacency. Understanding why that item is on the to-do list is the whole point.
Which is why the word transparent in the paper's title is so important. The agent shows its work. It tells you why it thinks you need that scatter plot. It's on the human to actually read that and engage with it.
So, the takeaway for everyone listening, use the tool, but don't outsource your thinking.
And for goodness sake, don't fake the TBD.
Right. If the agent leaves a placeholder, you'd better have the real data to back it up.
Absolutely.
The Paper2Rebuttal is up on our sites now. We'll also drop a link to the RebuttalBench dataset in the description.
It's definitely worth a look, even just for the agent prompting strategies they use.
Thanks for listening to this episode of AI Paper Podcasts. We'll catch you on the next one.